Hi all, welcome to lesson 2, simplifying radicals. I want you to pause the video for the warm up and try it on your own. Okay, so let's see, what are we doing here? We're simplifying these. You learned these properties of exponents on day 1. So lesson 1 has all of them. And what we're trying to do here is it's division and your bases are same. So what do? You subtract your exponents. So I'm going to rewrite the work, what I'm doing. You necessarily can skip that step, but I just want to show. So it'll be x to the negative 1 minus 2, and then y to the 2 second minus negative 4, right? If we simplify it, minus 1, negative 1 minus 2 is x to the negative 3, and then you have y to the 6th. You cannot have negative exponents, so what do? You flip it, flip the base. So what does it do? It'll be y to the 6th over x cubed. Number 2, we're simplifying this expression also. So if you look at the negative 1, it's raised to the whole thing. So what do? You're going to raise the coefficient to the exponent and then multiply the exponents. So I'm going to just do these arrows so you it makes sense to you. So let's multiply the exponents. So x to the 2 times negative 1 is negative 2, y to the negative 2, and 3 to the negative 1. You cannot have negative exponents, so what are we going to do? We're going to flip the bases. So if it's in the numerator with the negative exponent, it goes in the denominator. If it's in the denominator with a negative exponent, it goes in the numerator. So it will be 3 over x squared y. So let's get started with the examples. Before I even start with the examples, I just wanted to, if you see, I made up two lists of perfect squares and perfect cubes. Perfect squares are not the same. If you multiply a number by itself, it's a perfect square, right? So I wrote the first 10, and perfect cubes, I wrote the first 6. If you multiply the number thrice by itself, you get a perfect cube, right? So we would need them to solve these questions. So here it says, to simplify, reduce a radical expression, factor out the greatest perfect power. So when it says greatest perfect power, I'm basically looking at my index. What's in my index? Here it is square, right? Here it's square. If you look at C and D, C it's cube, D it's the fourth root. And we're going to skip letter E, so you can just cross that out for now. Okay. So I'm going to start with letter A, and this number negative 3, it really doesn't, I don't need to do anything with it till I simplify my radicand. So what do I need to do? How do I simplify it? If you look at 24, and I'm going to look at my perfect squares because we're dealing with square roots here, right? So 24 did not make the list up here, but I want to rewrite 24 as a product of two numbers. One of them is a perfect square. So think about it. If a number isn't, literally go to half of it. Is 12 a perfect square? Check your list. No, 12 is not in your blue list there. So check all the numbers below 12 that go into 24. And 9 doesn't, but 4 does. So can I rewrite it as 4 times 6? Now, how do I check if my variables are perfect squares or perfect power? You look at the index. Here, my index is 2, and look at my power. It's 4. So it has to be a multiple of your power. 4 is a multiple, so you don't need to break it. You just leave it as r to the 4th, right? So this is how you simplify it. That's your first step. Now what you're going to do, whatever is a perfect square, you're going to pull it out. So I'm going to bring down the negative 3. Square root of 4 is, it's all multiplication, remember. 2. And then 6 is not a perfect square, so the non-perfect ones go under the radical. And r to the 4th, square root of r to the 4th will be basically you're dividing your power by the index. So 4 divided by 2 is 2. So it is 2. So this would be negative 6 r square rad 6, and that is your final answer. Okay, so I would say pause the video and try B because it's very similar to A. Okay guys, so my 1/3, I don't know, I got these dots here. So my 1/3, I'm going to rewrite it as it is. Now 18 is not a perfect square. So again, think of one of these numbers from the list that goes into 18. Or you can think of it as, if 18 isn't, you literally go to half of that number. What's half of 18? 9. And check, is 9 a perfect square? Yes, 9 is. So 9 times what gives you 18? 9 times 2, right? And now look at this. This power is 5. Does 2 go into 5? No. So what is the number that 2 goes into? Can I break it down into 4 times y to the first? Right? And now whatever are our perfect squares, we're going to pull them out. So it's going to be 1/3. Remember, it's multiplication. Square root of 9 is 3. 2 is a non-perfect square, so it stays under the radical. Y to the fourth will become y square, and y to the first, it is a non-perfect, so that stays under the radical. You don't have to write y to the first, you can leave it as y, but I'm just doing it so that we understand what did we do. We're not changing the question, we just broke down y to the fifth as y to the fourth times y, right? Simplify this. So 1/3 times 3 is just 1, right? So it's 1 y square and 2y. Let us see. So now look at this. This is cube roots. So when we are working with cube roots, we need to look at our perfect cubes for the numbers, right? We already have a list of them, and 16 did not make my list of perfect cubes. So I need to go to half of it and see whether that number goes into 16. So half of 16 is 8, and 8 is a perfect cube, right? 2 cube is 8. So oops, so I'm going to rewrite this as cube root. I would say when you're writing the root, please make it smaller than the other number so it's easier for you to identify. This would be 8 times 2, right? Now to look at the power of the variable, must be a multiple of the root or the index. So if this is x to the 10th, I'm going to highlight these so we understand these better, right? And my root is 3. So this should be the multiple of 3. Is 10 a multiple of 3? No, it is not. Okay, but can I break it down? Yes, I can. I can break it down into x to the 9th times x to the 1st, right? And if your power is smaller than the index or the root, just leave it as it is. 2 is smaller than 3. I can't really break it down because it won't go into it. So now how do I simplify it? Just like we did for a and b. What's cube root of 8? It's 2. 2 is a non-perfect cube, so it stays under. Cube root of 9, or think about it as, you're dividing the power divided by the root. So 9 divided by 3 is 3. So x to the third. And x to the first is non-perfect cube, and so is y square. So this is my final answer. I'm going to rewrite it a little nicely. This is 2x cubed. That looks like really separate. And cube root of 2xy square. So before I start D, I actually wrote the powers of 4. So 1 to the 4th power is 1, 1 to actually any power is just 1. We should all know that, right? Try to remember that. 2 to the 4th is 16, 3 to the 4th is 81, and 4 to the 4th is 256, and so on. And you can find those. You can use the calculator. You don't have to memorize them, but it's good practice that you know what you know a first few. Not all of them, but first few, of course. So now what do I do? Again, it's same when you're breaking them down. The coefficient 2/3 really doesn't matter. We're checking if they are perfect fourth roots, then we're good. If they're not, then we need to break it down. So 162. If you look at this list here, 162 is not in my list. So I'm going to go to half of it. What's half of 162? 81. You can check 162 divided by 2, which is 81. So 81 is in there. Oops. I'm not sure what happened. So I can break this down into 81 times 2. Now look at my root. My root is 4. So I want to make sure these powers are either 4 or are multiples of 4, right? So is 8 a multiple of 4? Yes, so I don't need to break it down. So I'm going to keep it as it is. Y to the third. If you have a power smaller than the index, you just leave it like that. You don't really have to do anything. Now 14, z to the 14th. 4 does not go into 14th. What's the closest number to 14 that 4 goes into? It is 12. So if it's 12, how many z's am I left with? 2, right? So that's what you do. So now once it's broken down, all you have to do is take the fourth root, simplify it a little, and you're done. So 2/3. Fourth root of 81 is what? What number did I multiply? It's 3. Yes. And I'm going to set up my non-perfect ones. 2 is a non-perfect one. X to the 8th. Fourth root of x to the 8th would be you just take your power divided by your root. So 8 divided by 4 is 2. Y cube, it stays under. 12 divided by 4 is 3. And z squared stays under. Now let's simplify this. This is all multiplication, remember. Okay? So the 3's actually cancel out. So you have 2x squared, z cube, and fourth root of 2y cube